everybody. My name is Eyal, and I'm going to talk today from Utilight, which is a part of Laser. I'm going to explain about it soon. And I'm going to talk today about laser transfer printing as a solution for photovoltaic, microelectronics, and advanced packaging. So, about us. So, basically, we are an capital equipment company. We care about getting cutting-edge laser solution for mass production facility.
Microphone.
Oh, yes, sorry. Okay, so we care about deliver cutting-edge laser equipment for high-volume manufacturing, especially in the photovoltaic area, but also in semiconductor. Basically, we started with DR Laser. DR Laser is a photovoltaic #1 market leader for laser equipment for photovoltaic. It was established in 2008, in Wuhan, Optical Valley. And Utilight is an Israeli startup established in 2009, dealing with the pattern transfer laser technology. And after developing the system, we were acquired by DR Laser in order to put it in large scale in the photovoltaic industry. In total, there's this operation of DR Laser, the Israeli center. We also have a Singapore center for semiconductor. The overall operation is about 1,500 people doing all of these activities. So again, we are a photovoltaic laser company doing all kinds of systems from selective emitter ablation, local doping, scribing, microetching for back contact solar cell, and so on. And of course, we have developed the laser pattern transfer equipment for metallization of photovoltaic. We are basically a market leader for delivering the equipment. And so far, since 2012, DR Laser managed to deliver almost 7,000 different laser systems to our customer, mainly in the photovoltaic industry, which, as you know, has grown significantly in the last decade. We also try to deal with some semiconductor laser-based equipment, but I want to go directly into the laser transfer technology. So the technology that was developed by Utilight is quite simple, and it comes to compete with conventional screen printing. So what we are doing, we are taking a pattern that we defined the shape, the pitch, the cross-section, and the aspect ratio of this pattern. We can do it on a variety of substrates. Different platform can use different substrate for this. It's a mashless technology, not like screen print. It's got a very high density of the pattern, sometimes even higher than the product requires. So you can use it for multiple times. And it's a very low cost. Again, we have to compete with the cost structure of the PV industry in China, as you know, is very, very low. So we have to keep it low cost and make it be able to be used multiple times. So this is the first step. Then we just filled this pattern with standard paste. And from the beginning of Utilight, 2009, our goal was to use standard material and not confront the industry with trying to adopt new materials and new ink and so on. So we just use standard paste, and we just fill it into the trenches, and then we can go to the laser transfer, which is basically counted on the laser-induced forward transfer, what's known as lift. So we really create a local sub-micron interface reaction between the laser energy, the paste, and the sidewall of the trench to release in one shot a finger on the photovoltaic cell or any conductive or any other conductive pattern. Again, this is a non-contact technology. It allows you to reach very fine line. You can see here 10 micron over 16 micron of a conventional photovoltaic silver paste. Again, high aspect ratio. Since we are an equipment builder, a cutting-edge equipment builder, this is a high-volume manufacturing production. We have developed a totally new scanner that enables us to scan at 350 hertz. So we print 150 fingers, which is typical for photovoltaic cell of 182 millimeter, in less than 1 second, which is the requirement for the photovoltaic industry. And the fact that we print line after line allows us for some dynamic changing of the actual pitch you get on the final substrate. So this is the core concept of the PTP technology that we have developed. And this is some of the capability. Again, silver paste finger for the TOPCon cell,